Hello, my name is Courtney Sand, and I will be bringing you up to date on the new communication platform for open systems features that are available in ClearPath OS 2200 Release 20.0. In this presentation, I'll introduce the new communications platform for open systems, CPCommOS, features in this release. During the SSL TLS handshake, the client authentication mechanism provides optional functionality, allowing a server to request that a client sends a certificate to authenticate itself. Currently, when an application on the OS 2200 is acting as a client and the remote server requests a certificate, CPCommOS sends the certificate configured on the SSL TLS security configuration statement corresponding to the client program. With this implementation, the certificate likely identifies the server rather than a specific client user program on the server and is therefore not a viable way to differentiate one OS 2200 user from another to the peer system. With this new feature, CPCommOS adds a capability for an application to pass a PEM formatted certificate and private key and an optional password for use in the SSL TLS handshake using three new API procedure calls. SSL TLS Secure Listen with Certificate v4 v6, SSL TLS Secure Connection Open with Certificate v4 v6, SSL TLS Add Connection Security with Certificate. CPCommOS uses certificate and private key pair provided on the API procedure call instead of the default certificate and private key pair configured on the SSL TLS security configuration statement in use for the application. Since the application can now provide the certificate and key needed for the SSL TLS handshake, this feature also adds a new optional client-only field on the SSL TLS security configuration statement. Use this field to tell CPCommOS that programs using the SSL TLS security configuration statement act only as clients and never as servers. If you set the client-only field to yes, CPCommOS does not require a certificate and key pair on the configuration statement. If you specify yes and do not provide a certificate and key on the configuration statement, or using the new API procedure calls mentioned previously, CPCommOS cannot send a certificate if the server requests one. If you set the client-only field to no, the default, a certificate and key pair must still be configured on the configuration statement. CommAPI and CPFTP take advantage of this new capability in CPCommOS. For more information, please refer to those products' respective documents to determine how to properly configure and use the added functionality. This feature allows CPCommOS to use the TLS version 1.3 protocol, the latest and most secure transport layer security protocol. By default, CPCommOS now attempts to use the TLS version 1.3 protocol and a TLS version 1.3 cipher suite when performing an SSL TLS handshake. If TLS version 1.3 is not supported by the peer system, CPCommOS attempts to use TLS version 1.2. Administrators can use the protocol's desired field on the SSL TLS security configuration statement to select exactly which protocols are right for their needs. This feature includes the addition of 5 new TLS version 1.3 only cipher suites and 3 additional TLS version 1.2 only cipher suites to the already allowed TLS version 1.2 cipher suites. Most of these cipher suites are included in the Unisys determined list of default cipher suites, or you can specifically configure them using either the cipher suite list or cipher suite minimum fields of the SSL TLS security configuration statement. The new cipher suites are listed on the slide. Also, as part of this feature, CPCommOS removed support for a set of cipher suites considered too weak for safe use. We've listed these cipher suites on this slide. Lastly, CPCommOS removes support for digital signature algorithm, DSA, certificate, and private key pairs. For this reason, CPCommOS now ignores any DSA certificate file and DSA private key fields on the SSL TLS security configuration statement. The SSL TLS component in previous versions of CPCommOS supported TLS versions 1.1 and 1.2 by default. If your application required TLS version 1.0 support or SSL version 3.0 support, you have to specifically configure it for use in the CPCommOS configuration. The protocol's desired field of the SSL TLS security configuration statement specifies the versions of the SSL TLS protocol that you allow. You can configure specifically desired protocol versions. You can also omit this field or specify all, both of which mean that CPCommOS allows the default list of protocols. This default list no longer includes TLS 1.1. If you need SSL version 3.0, TLS version 1.0, or TLS version 1.1, you must specifically configure them by naming them on the protocol's desired field. If you use the default list and an application has problems opening a TLS connection after upgrading to this level, it likely means the application does not support TLS versions 1.2 or 1.3. Be prepared to configure TLS version 1.1 or TLS version 1.0 in this case, or investigate whether the application can be updated to use newer and more secure protocol versions. Prior to the introduction of this feature, the only way to control TCP Keep Alive settings or functionality was to have CPCommOS application developers use CPCommOS API procedure calls. This feature adds new optional Keep Alives intervals, and Keep Alive sends fields on the process configuration statement to control applications' use of TCP Keep Alives on a per application basis. Use of these fields overrides any choices set on the API procedure calls the application makes for setting TCP Keep Alives. This feature implements the new resolve command. If you provide a name, CPCommOS displays all associated IPv4 and IPv6 addresses that resolve to that name. If you provide an IP address, CPCommOS displays the name that resolves to that IP address. This command is beneficial in troubleshooting domain name system issues. CPCommOS now allows you to enter a command that clears the contents of the domain name resolver (DNR) cache within the SAIL environment. Prior to this feature, there was no documented way to clear the DNR cache. The DNR cache contains information about domain names, such as domain name to IP address pairings and IP address to domain name pairings. Clearing the DNR cache forces SAIL to obtain the information from the name servers again as needed. Thank you for listening to this presentation. For more information, please refer to the Communications Platform for Open Systems Configuration and Operations Guide and the Communications Platform for Open Systems Programming Reference Manual.